I mean, seriously, have you ever stopped to think about it? How do billions of devices all talk to each other at the same time without it just being total chaos? It sounds impossible, right? But the answer is actually super elegant, and it all boils down to one single powerful idea. And that idea is something called a protocol. Really, all a protocol is a shared set of rules. You can think of it like grammar for computers, or maybe digital etiquette. Without these rules that everyone agrees on, all that data flying around the internet, it would just be noise, complete gibberish. You know, it's actually a lot like how we talk to each other. For us to have a real conversation, we need these unspoken rules, right? We need a shared language, we say hello and goodbye, we don't talk over each other, hopefully, and we check in like, did you get that? Well, it turns out computers are basically the same.
All right, so let's dive in and look at the most important rules for that digital conversation, the ones that are the foundation for pretty much everything we do online.
And that foundation is called TCP/IP. Now, what's interesting is that it's not just one rule. It's more like a team of protocols working together. And on that team, there are two superstars that you really need to know about, TCP and IP. Okay, so let's start with IP, the Internet Protocol. Its job is super simple, but absolutely critical. It's all about addressing. It's like the postal service of the internet. It slaps the sender and receiver's address on every little packet of data and just gets it headed in the right direction. But, and this is a huge but, notice that last point. It does not guarantee it'll actually get there. Right, so think of IP as the postman. The postman knows your address, and they'll do their best to get the letter to your mailbox. But they don't promise it won't get lost in a sorting facility or get rained on or delivered with your other mail out of order. IP just handles the where. It doesn't worry about the how or the if.
And that is exactly where its partner, TCP, steps in. TCP is built right on top of IP's I'll try my best system, and its entire job is reliability. It's the manager. It's the one that checks to make sure every single packet arrives safely. If one gets lost, TCP demands a resend. If they arrive out of order, TCP puts them all back in the right sequence. It even manages the speed so things don't get all jammed up.
So if IP is our casual postman, TCP is like this incredibly meticulous, maybe a little obsessive, personal assistant. This assistant numbers every single page of a report before handing it off to the postman. Then they call the person on the other end and ask, hey, did you get all 37 pages? Are they in the right order? Is page 12 crumpled? And if anything is wrong, anything at all, they send a fresh copy immediately. This is why your emails and websites show up perfectly. It's TCP working tirelessly in the background, checking every single detail.
But, okay, what if you don't need all that? What if you don't need that meticulous assistant? What if what you really need is just raw, blazing speed, and perfection is in the top priority? Well, for those times, the internet has a totally different tool in its toolbox. And that tool is UDP, the User Datagram Protocol. If TCP is a personal assistant, UDP is like an old-school town crier. It just stands in the middle of the square and shouts information as fast as it possibly can to anyone who's listening. It's not going to stop to ask, hey, you in the back, did you hear that? It doesn't care if you missed a word. Its entire philosophy is shout the info and move on. So yeah, it's incredibly fast, but also completely unreliable. So what we end up with are two completely different ways to send data. And this leads to this really fundamental trade-off that's at the very heart of the internet. What's more important, speed or certainty? It all comes down to picking the right tool for the right job.
And this really lays it all out, doesn't it? Look at this. You've got TCP over here with its amazing reliability, its error checking, its perfect sequencing, the whole package. And then you've got UDP with just raw, unapologetic speed. And pretty much every single app you use on the internet has to make a choice between these two totally different ways of doing things.
So when is that certainty just non-negotiable? Well, think about it. When you're downloading a file, right? Or sending an important email, or just loading a web page, you need every single bit of that data to be perfect. One missing piece and the whole file could be corrupted, the whole website could be a jumbled mess. For these jobs, it's gotta be TCP. There's just no other way. Okay, but what about when speed is king? I'm talking about things like online gaming, or video calls, or live streaming. That's where UDP is absolutely essential. Imagine you're on a video call. Which is better? A tiny little glitch in the audio for half a second that you barely notice, or the entire call freezing for 5 seconds while TCP is frantically trying to find one lost packet? Yeah, you'd take the little glitch every time.
A tiny imperfection is a price worth paying to stay in the moment.
All right, let's make this real. Let's connect it directly to your digital life. How about a little pop quiz? Let's see if you can figure out which protocol is running in the background of some of the apps you use every day. First up, you're chilling, watching a movie on Netflix. Is that TCP or UDP? Think about it. What's more important? That the movie keeps playing smoothly, even if you get a weird pixelated frame for a split second? Or that the whole thing just stops, freezes, while it waits for a perfect piece of data from 3 seconds ago? Yeah, for the stream itself, speed is king. That is a classic job for UDP.
Okay, next one. You're sending a message on WhatsApp. What's it going to be? TCP or UDP? Let's see. Would you rather that message show up instantly, but maybe with a few words missing? Or arrive perfectly, exactly as you typed it, even if it takes a tiny fraction of a second longer? Yeah, no brainer, right? You need it to be perfect. That is 100% a job for TCP.
And for the last one, you're in the middle of an intense match of Fortnite. TCP or UDP? Come on, this one almost answers itself, doesn't it? In a game that moves that fast, getting perfect, reliable data about where your opponent was 3 seconds ago is completely useless. You need to know where they are right now. That is the textbook definition of a job for UDP. Speed over everything. So there you have it. These silent, invisible rules, this constant battle between perfection and speed, they've shaped the internet for decades. They are the absolute bedrock of our digital world. But here's the thing. As we start moving into a future of, virtual reality, instant global communication, technologies we haven't even dreamed of yet, our needs are going to change. And that leaves us with a really big question. What new rules will we have to write to build the internet of tomorrow?